Hi guys, Ashwin here. This is episode 3 of Sui Deep Dive series, and previously we have covered about witness patterns in theoretically, and in this video we are going to discuss how we can implement witness patterns and how it's going to eventually increase our security in the contract by giving multiple access controls within the contract, that is within our module. Then we will go into how a single owned cap itself, owned object is going to have an pretty important role in the contract. Then we will go to making sure that we are implementing it in our token module. Then we will go to the next part of upgrading our contract. So which I have discussed previously, we shouldn't upgrade our token module. We can upgrade our other contracts, but especially the token module is pretty sensitive in the community, so we shouldn't upgrade it. But for practice purpose, we are going to uh, you know just implement a migrate function and upgrade our contract, and I will show you how it works. Then later on we will go to there are some pretty standards in coin module. Say if if some 50,000 tokens is hacked in our from our token module, how we are going to prevent it. You have some functions called as you have some capability objects called as DenyCap in Sui module, which you are going to use it, and you are going to blacklist some wallet, and you are going to make sure that that exact wallet can't make any transactions with our token. So that is something DenyCap can do. And later on we have some other capability, something very much similar to DenyCap, and we will explore them one by one. Yeah, let's get started. Let's get started with the coding then. So what we need is we need a witness object, and we need a admin registry object. We need this admin registry object to note down the registry, or to note down the owner address and admin addresses, everything. Then later on we need the owner cap. Okay, so owner cap object. So let's just have the witness object. Then we need the admin registry object. Okay, so I will initialize the fields now. What field we need? We need an owner address field with an address type. Then we need admin address. We have some 2 or 3 admin addresses right now, according to my mind. So let me have it as in the type vexet. Okay, and I will just tell you what is this vexet soon. Just I also need to import it. Okay, so I've imported it. Now we need the owner cap. As key store, and also UID. Okay, okay, we have initialized every objects that we need. If we need anything else, we can initialize it later. And now we also need to have it in the init function. let us also initialize the admin registry object. We need to initialize the owner address to the sender, and we need to initialize the admin address, which we are going to have it in the vec set. We are going to call the empty function. Okay. Which is going to be of type address as we have set it above. Okay, we have it as okay. Next, I will tell you the difference between vector and vec set. So let's say in vector you can have multiple items, right? Say 1, 1, 2, 3. You can have unique as well here, unique items. But in vec set, what is the advantages? In some times we need only the items to be unique, right? We can have 1, 2, 3 and 4, and we can't have 1 because 1 is already existing. We can't have unique items. This is the special collection in move, and we are using vec set because we have admin addresses to be unique, right? We don't want 0x1ab and 0x1ab multiple times in the same vector, so we are using the vec set module here. Okay, so we have initialized admin registry owner cap, and yeah, let's also initialize the witness object. Yeah, there is no need because since I'll get back to this. I'll explain about why we are not initializing the witness here in a second. Now we need to make sure that we are making it as a shared object, the admin registry. And also the owner cap should be sent to the deployer. Deployer is gonna be me, and yeah, that is done. Now I will just give you the flow how it's going to look. So we are going to call a single entry function, which is going to be called by both entities, admin or owner. So when admin or owner is going to call an entry function, he is going to get a witness generator, witness object generator, and that witness object is going to have a drop ability, right? So when there is a drop ability, when you pass that witness as a parameter, that object as a parameter to another function, when the function ends, that exact object is going to get dropped. So you use that witness object as a entry, as a guard, to be just easy to understand. You use that witness object to call and add admin function. Then after the add admin function is ended, that exact object is dropped. That's what I'm coming to tell here. So this is the flow, and yeah, let's have an entry function called by two entities here, just for naming. Okay, and it's not going to return anything, but we also need some things to be passed. internally we pass the generate witness function and add admin function. This generate witness function is going to return a witness, right? So function generate, this is going to be a private function, and it's going to return the witness, which is going to be okay, and it's going to return. It needs some assert functions here as assert statements, but we are neglecting that in our token module currently because this is insecure token module that we are coding right now. Yeah, now let's continue with this. Okay, now what we will be passing inside this two entity is we need the admin registry to be passed, admin registry shared object ID to be passed, and we are going to have it as okay. Now we are just referencing it, node address, and we also need which admin address to be added, right? To add, okay, so I will have it as with address type. Yeah, we'll add it if we need it. Then we also need to have a assert statement here, right? Say this function is called only by the admin or owner, so we need the transaction context for it. We'll just reference it for now. And we will import the transaction context module and call the sender function and pass in the CTX as referenced CTX. Okay, and then later on we use that sender to have an assert statement here. Assert statement, this assert statement checks whether the exact caller of this function is an owner or admin, right? So we just need a ternary operator, and we use this, we just code this assert statement out. Assert statement is going, we are going to import the contains function, and all we need is a reference of the admin address. We are checking whether the vector is containing the sender address, right? That is the deployer address, sorry, the one who is calling the one who is calling this function, okay. Yeah, it's expecting and yeah, okay, understood. Then also we need the admin registry, a ternary operator, owner address. just setting an error code here and set the constant above. Error codes should be always U64. Okay, we are just checking it here, which is good. Let me check whether I am okay. The video is getting recorded. Now we are going to call this admin function. Add admin function. This is going to be a private function. And the first one is going to be witness, and it's going to be of type witness. We will pass that here. Okay, then also we need admin address to add, right? And also we need to check whether the admin is already added here, which we are going to neglect it right now. We are going to do is we are going to insert this address, and also we need the admin registry, a mutable one. Going to pass the mutable admin registry. One second. We are going to pass which we are going to add, right? The address and the key. Expected mutable field. Yes, I missed the order. It's expecting self and key. It's going to be vector set and mutable admin registry. Okay, so the order is quite different. And we are not getting into this, and to the admin address field and admin to add. Okay, admin is added. We also need to have event emitters here, which is we are going to neglect it for now. Okay, the first one we need admin registry also to be passed. You also need registry to be a mutable one passed in. Okay. Yeah, this is the witness pattern that I have discussed about. So, what we have coded now is, so let's say this function is called by the owner also. It checks whether the caller is the owner, and after a check, if he or she is an owner or an admin, both of them can call this single function and generate the witness, and that witness can be used to call this add admin function. We are just having with the prefix of underscore because we are not going to use this witness, just we are having it to make sure that that add admin function can only be called with an witness type object, right? So after this is this witness is generated, it's going to get passed into this add admin function. After we add the admin, it's going to get dropped here. So this is the witness pattern that I wanted to discuss with you guys. Let's start with upgradability now. So let's talk about the upgradability feature that Sui provides. So whenever you deploy a module, you get upgrade capability object. You use that upgrade capability object to upgrade the contract to version 2 or version 3 whenever you want, right? So that is the whole purpose of upgradability. So in EVM we have the proxy contracts, right? In here we have this exact concept of upgrading the contract using the upgrade cap object. So in the token module we would be deleting the upgrade capability object so that we make sure we have the credibility between the community and the token itself. So here, just for practice, what I've done is I've included some versioning in the contract and added a migrate function. So what are the prerequisites or the requirements that you need to satisfy for having your contract in upgradable fashion is you have a migrate function and you have versioning around the shared objects. So whatever shared objects you have in your contract, you should make sure that you mention the versioning so that whenever you are upgrading to a version 2, you trigger the migrate function. So the flow would be you change your contract version. So as you can see here in the the current version, I have it as 1, right? So when I am switching it to version 2, I will change this to 2, and I will trigger my upgrade capability object. Like there will be upgrade command, and I will give the upgrade capability object id as the argument, and I will just trigger it. And the exact contract it's in the state of upgrade state, but it's not yet fully transitioned. Then we will have the migrate function triggered. So here is the migrate function for in this exact versioning in the sense, like in this exact tutorial, what we are doing is we are having the max admins as version 1, right? In the version 1 we have 2 admins, so I have initialized here as 2, where it is, yeah. Okay, so 2 admins, and in the migrate function, I will make sure that I am switching it to 4. Okay, max admins as version 2, and the version 2 constant, if you see, I am switching it to 4. So when I am switching it to 2 and I am making switching it to version 2, then it is not yet fully transitioned, but when we trigger the migrate function, you you transition your whole module from 1 to 2, okay, version 2, which will make sure that your exact max admins becomes 4. Okay, in our current tutorial I will demonstrate it in the CLI itself, so that you guys will get a clear understanding of it. So this is our token module. I just cleaned up the code base and added the versioning around everywhere, and added this exact migrate function. It's a very simple migrate function, and we have our witness functions, and yeah, everything else remains the same. So it's in version 1. Yeah, let's make sure I just I'll just deploy it now. I'm deploying it with version, this is version 1, okay? This is version 1 of our contract. Okay, we have a version 1 of the contract. I need this digest now so that I can call the upgrade capability, that is upgrade command. I'm just constructing it because in the CLI we need it in the certain order, right? So now we will upgrade it using this exact, where to say, yeah, here it is, right? It is of type UpgradeCap, and we are going to use this exact object ID to upgrade our contract. You can view this as well. As you can see, this is of object ID and object type, upgrade capability, address owner, and everything. Version is 1. Okay, so what I'm going to do is I'm going to switch it to version 2 now. It belongs to this package 0xcf, and as you can see the package ID, right? So this exact version will change now when I trigger the migrate function. We will check that once. And also since we have deployed it, I will also show you the admin registry object, right? So that shit. You can check the exact max admins, which is 2, and the versioning field we have set it as 1, and everything would change now when I trigger the migrate function. Okay, just hear it very well, guys, because we are not triggering the upgrade command and changing the versioning itself. So we are just using the migrate function to migrate our version 1 to version 2. Okay, so that is the first thing. Then so what I'm doing is I'm Sui client upgrade capability, and I'm passing the upgrade cap ID, which is from here. Okay, FA0F, and I'm passing it, and it's successfully upgraded, not it totally upgraded. You just see what is the mutated objects. Now as you can see, it's in the mid phase, like it's in version 2. The package ID also got changed. So what happened is the current version 1's upgrade cap is used, and it is like probably it gets consumed under the hood, and we got the new upgrade package ID, and as you can see FA0F, that remains the same, like that ID remains the same, but as you can see the version 2, the version field changed to 2. So we didn't initiate the upgrade cap, right? As you can see in the contract, we don't have any object initiated like upgrade cap. This is totally provided by the Sui itself, like the framework itself. So now what we are going to do is we are going to trigger the public, that is the entry function migrate. So when we do that, still I can show you the the admin registry owner address. Yeah, this is the admin registry object, and you can see still it's in version 1, right? The whole module is in still version 1, and the exact upgrade cap is in version 2. Okay, so now what we will do is we will change the whole versioning of the module 1 to, just we are upgrading it to module 2. Now what we will do is call the migrate function now. So whenever we use the upgrade capability, so as we have did here, you can notice that there is some mutated objects, right? So the package ID will get changed. So it's 69 here. Previously, when I'm showing you, it is 3E. Okay, so it is in the versioning 2. So there is an empty package ID to say, let's say the whole contract, still the version 1 is remain, is still exist, but version, we are transitioning the whole version 1 to version 2 now. I will post a detailed blog about this to be still more in detail. I'll copy this package ID now. So I will also explain the arguments that we are passing. So whenever we deploy the contract, we have the shared objects, right? And also the owned objects. We get object IDs for each and every one of them. We pass the object IDs as arguments here. So when we see the migrate function, you can see the admin registry, treasury object ID, and the transaction context here. It comes from the user side itself. You don't need to enter that. So when we see here, you pass in only the two object IDs, right? You're not passing anything for the transaction context itself. So our contract is migrated from the version 1 to version 2. I can show you the admin registry now. The max admins got changed from 2 to 4. So what we can do is, it's the migration is done. So whenever we want to call the contract, we will be using this exact package ID. Where it is? Yeah, here it is. Here it is. We use this package ID to call, since we are transition from version 1 to version 2. If you try to use version 1 contract also, it will throw you the error, because we have transitioned from version 1 to version 2, right? So it will throw you out the error. So now what we are going to see is, let's say I want to upgrade some functions, add some more functions. What you will do is you add some functions here, and then you say in the migrate function that these are the shared objects that gets changed, like we say here, admin registry dot max admins is the change here, and you mention it in the migrate function. Then you make a change here in your current versioning to 1 to since in the next version, like actually what we should have done is we should have changed this to 2, right? But I didn't do that. We should have done that, because in the Sui scan it will be, your contract will be visible for the whole community. So the current versioning should be changed to 2, but that's a mistake from my end, but we should have done that. So then later on, after you change the current versioning, then you change what is the changes that you are updating in the migrate function. Then later on, what you are going to do is you are going to trigger the upgrade capability command, which is going to partially transition your current version to the next version, and still your current version is existing, and you can make calls to the current version. But then when you want to upgrade totally to your next version, you have triggered your upgrade capability, right? Using your upgrade capability, you might have received your new package id. You use that package id to call the new migrate function, and you totally transition from module the current version to the next version. This is the whole flow. Yeah, I will post a detailed blog about this soon. Yeah, thank you, and